On behalf of Web-based Solutions, I would like to welcome you to our today's webinar, Cloud Essentials for Architects. My name is Mikhail Vladimirov. I'm with Web-based Solutions, a training and consulting company providing training classes in system administration, programming, and architecture to clients across the globe. Here's our agenda for today. It would be a pretty straightforward coverage of fundamentals of the cloud. So I understand, and this is my assumption, that the audience has somewhat limited idea of what the cloud can give you as designers of software solutions, as architects. So we would also touch on some technologies which underpin the cloud platform. We would also talk about cloud economics to see how you can benefit from the value proposition of the cloud. And cloud services would give you a sense of what you can find and leverage in the cloud. So that's one of the very favorable aspects of cloud computing, where you can avoid reinventing the wheel and you can provision a system that is already available. I would welcome your feedback and your questions as we go. So if you feel that like asking a question, or maybe you would like to get some clarifications, please ask your question via the questions panel. You can detach it and you can put your question in there. Don't put off until the Q&A session that we will have at the end of this presentation in about 50 minutes or so, depending on how fast we go. This presentation is scheduled for 1 hour, and we will honor that. If you, I guess, feel like dropping off, no problem. I'm not going to do a kind of a round table discussion at the end of the presentation. So it would be me talking, taking your questions, and that's it. Okay. So hopefully that's so much for housekeeping, pretty straightforward. So let's get started. So let's define what the cloud is. You would normally see this cloud shape in your tools that you represent some sort of wide area network or other distributed systems using the cloud as the concept, as a metaphor. So I guess cloud just derived that metaphor, and people coined this term to describe anything that you can develop on the internet as a whole, where you have some computing facilities deployed in data centers, and you would use that client-server paradigm using TCP, TCP/IP, HTTP, HTTPS, and all other TCP-based protocols to access those resources. It might help to draw an analogy with cloud computing by comparing it with the traditional electrical power grid. So that hydro or electrical power distribution grid generates and delivers electricity from suppliers to consumers. So that's the familiar idea, concept. And you can liken power stations, which are responsible for generating electricity, the hydro, as data centers. The specialized centers which do that particular part of delivery. Transmission lines which deliver power to your houses, to your offices, can be compared to the TCP/IP network. So this is a familiar concept to us. And all those electrical appliances that you have at home or at factory, in the offices, are client applications. So whether it's your TV set or your fridge or your toaster, those are electrical appliances represent the actual solutions, software deployed in the cloud. When you use those appliances, you consume electricity, and that's where that similarity with the utility service comes into play. So you can see the computing cloud as a utility service which provides you the necessary computing resources, whether it's CPU, whether it's memory, network, persistent storage, and what's not. Clients, those consumers, pay on per consumption base. Whatever you consumed, you would pay only for that. Your utilization, your consumption of the electrical power is metered using the electrical meter of sorts. And if you would like to consume more, if you, for example, have 2 fridges, or you would like to probably set up a new media center in your basement, you can always be confident that your power station, your power producer, your company, your utility service would oblige your request and would provide, as long as you're ready to pay for that. And that is very similar to what you have with cloud computing. And it's much more efficient to use that facility as opposed to creating your own power generator, probably patting yourself on the back saying, I'm so smart, I have this gasoline-driven power generator. But it's probably not the best in terms of economy, in terms of the actual utility. This picture from Wikipedia summarizes everything in a very nice consolidated picture. Let me just dissect it in slices so that it makes more sense. So we've got 3 layers. We've got infrastructure, we've got platform, and we've got applications which run on the platform. So this is the cloud. The clients might be any smart devices, smart agents that understand how to interact with the cloud. And as I mentioned, it's a client-server paradigm where the client is aware of the underlying protocol to connect, and the cloud computing uses the TCP/IP stack and anything on top of that. So you can use smartphones, laptops, servers. You can create hybrid clouds by exposing some of the functionality that you have on-premise behind the firewall, the corporate firewall, and build a bridge between the public cloud and your private cloud. Desktops and tablets, so any smart devices can connect to the cloud. So let's take a sequential look at the infrastructure, platform, and application layers. Cloud are built on the virtualized platform where you've got resources exposed to you, ready to use off the shelf, and usually you can have a programmatic access or you can use UI of sorts. Admin dashboard is very popular way to configure and manage all the life cycles of your resources. So the virtual machines underpin your compute aspect of the cloud. The block storage provides the necessary storage capacity which can be attached to your compute servers, to your virtual servers. And network provides virtual private networks, and if you wish to, you can expose your computing infrastructure to the outside world, to the internet. At this level, you would be dealing with infrastructure as a service, and you would have the minimum, the lowest possible level of accessing resources. Some of the companies are currently pursuing that path of exposing metal as a service, where you would actually get a physical machine and you would be deploying things on a dedicated server. It's a very small niche computing model. Normally you would be dealing with infrastructure at the lowest level. Built on top of the infrastructure as the layer is the platform as a service, or PaaS. We will be talking about IaaS, PaaS in a moment. At this level, you would have a higher level of abstraction of those underpinning resources, and you would probably have something in terms of runtimes, whether it's .NET platform or Java virtual machine, or runtimes for your favorite scripting languages like Ruby and Python. You would also have other facilities such as identity management, which would allow you to manage your users and roles, which is also quite tightly integrated with infrastructure as a service. You would have object storage where you would upload your images, your large data sets, which would be stored, retrieved, and managed in any possible way supported by your cloud vendor. Queues are also sort of de facto service present on platform as a service, which gives you a chance to build asynchronous kind of a message-oriented middleware where you would achieve some benefits of distributed asynchronous communication. Databases might be NoSQL, relational databases, which are exposed as a service. On the platform as a service, you operate as per API. You don't have access to the underlying file system. You don't have, probably most likely in most PaaS platforms, you won't be able to use your programming language to the fullest. For example, you won't be able to use input-output API or managing threads on your own, or some other low-level memory management operations would be banned. For example, if you use Python, all those C-based extensions to Python are blocked. So whenever you make a call to that API, which loads the C library, would be prevented. It's very unlikely, but that's the limit of some of the platform as a services. Other platforms, they don't have this limitation, so you can leverage the fullest range of your APIs. Application as a service or software as a service sits on top of platform as a service, or it can sit directly on infrastructure. And at this point in time, you would have a much higher level of applications. So you would have collaboration, communication, finances, all those tools and systems which would be available as software as a service, application as a service. So enablers. Ideas behind cloud computing have been, I guess, derived from a number of different IT areas. And experience and insights acquired during running large data centers and doing the collocation of web services helped gain the necessary insight and confidence that that model can be extended to the cloud. Also, insights gained during running grid-like systems also gave enough understanding of how you can virtualize those resources, how you can build powerful computing pipelines. It's interesting that sometimes people confuse grid computing with the actual cloud computing. And even though they look similar in some aspects, the key differentiator here is that grid computing mobilizes resources to serve the needs of probably a single user or very few users, as opposed to cloud computing model where a fraction of resources, quantum of resources, is allocated to a number of tenants, where you would support probably hundreds of thousands of users running on the cloud platform. So that's the main differentiating factor. But underneath, they might implement certain things in the same way. Virtualization was a key technology which made it possible to achieve higher server density and being able to provide that service, the computing service, as a service. So it helps you with management and pretty much reducing your operational costs. And that's how Amazon were able to expose part of their functionality, which was built around those concepts like virtualization, abstraction. And at a certain point in time, they just realized that, it looks like we have already built that infrastructure that we can start sell to our clients. It is a very nice business model for us to share a fraction of our resources, and as they've been pursuing this path, they realize that that would be a great way to build business on the cloud-like platform. By the way, those people who come from IBM mainframe part of the world, you would be surprised possibly that IBM positions the IBM System Z or System Z as a cloud platform of choice, because IBM was behind many of those technologies like virtualization, system partitioning, and service on demand kind of model. So IBM probably, or mainframes from IBM, can be viewed as the forefathers of the cloud. So I already mentioned grid computing versus cloud computing differences, and this slide summarizes all the key points that I mentioned. So grid, again, is designed to service very few clients, probably just a single user, and cloud is designed to service multiple tenants. So that's the biggest differentiating factor. Some of the aspects that make cloud computing very appealing to businesses and technologists is that cloud computing is elastic, so that elasticity comes quite natural with the nature of technologies which enable the cloud, like virtualization and providing services on demand. One aspect that you should look for is how fast your system can react to an increased demand. So elasticity is needed to accommodate the growing demand for your services, where the incoming traffic all of a sudden spikes because of specific promotions that you have, or probably it's the end of the month, or maybe it's particular part of the year where people are very active on the net. And at this point in time, cloud is giving you the chance to leverage that elasticity of providing additional resources needed to cope with that growing demand. But the factor, that metric that is very important, is that how quickly, how fast your system can react to that growth. Sometimes there is certain latencies. It might be a matter of probably tens of seconds, up to a minute, maybe more. And you would need to, as an architect, as a designer, you would need to think about how maybe do prototyping and see how actually you can quickly adapt to that growing demand. And there are some solutions specific to a cloud platform of thoughts of choice that you are using. Sometimes you would have sort of a whole standby of the necessary amount of computing capacity waiting for that spike. But that comes at a cost, because even though you are not using those resources, you are charged per uptime, not per actual CPU cycles consumed. So even if you run a service in that idle mode, still it generates some load on the server, on the underlying virtual server, and the uptime counts towards the overall bill. So there are some techniques for that. You can, for example, use lightweight virtualization like Docker or LXC or any other systems that allow you to create a high density lightweight virtualization on top of specific virtual server or node that you have up and running. So it's one of those things that you can use to match your bill with actual demand. So when you have that cloud computing model, it facilitates lots of things. First, you wouldn't incur that fixed cost expenditure where you would need to purchase actual hardware or probably facilities to install the racks of those servers. So all those things are gone. You are only dealing with the variable costs, the salaries, fees, and things like that. Your business would appreciate that model because you would be able to provision the system on demand, ad hoc, when you need it. It helps with business agility, faster time to the market. We are going to talk about the provisioning aspect of the cloud in a moment. But overall, I guess it makes sense to leverage what cloud gives you, because in many cases you would be, if you haven't started using cloud in your organization, it would probably be a good idea to start a small proof of concept project and see how you can help your business out with the cloud. Amazon, I'm not affiliated in any way with any of the cloud vendors, with Microsoft, Amazon, or Google, but I guess it looks like Amazon is the leader in this space. Of course, it's a very packed area. Lots of action is going on. Things might change, but Amazon has established themselves as the leader. And partly it's due to the very nice way of naming their systems in a sort of scientific-looking way. For example, EC2 is the Elastic Compute Cloud, which is the compute part of their cloud. Sounds like energy equals MC square, things like that. So they've got Elastic built in the name of the service, which is also another nice move. Okay, so we've got a question. Will cloud take over the individual organization's traditional data centers, or will both exist? I would say they would both coexist, and I would say I would add this peacefully. There will never be a fight against this and that. I would say we have reached a point in our life in IT that it's not about or, us or them. It's about and. It's about on-premise, your own data centers, and your public cloud, your private virtual cloud, created, encapsulated, and deployed in the public cloud. And that hybrid model, which I'm going to touch in a moment, helps you to absorb those spikes in user activity. So you might rate your system as ready to cater for 80% of your user demand, but those 20% that you expect would be on top of the regular workload probably be very expensive to accommodate in your infrastructure, meaning that you can outsource some of the computing needs to the public cloud. And whenever that spike in user activity happens, your traffic that your client base drives against your systems just max out your infrastructure, you would nicely burst the cloud. That's the term used. And you would go and outsource, redirect some of your clients to that segment on the public cloud, which would handle the resources, and when the traffic slows down, you would be able to scale down, shut down your public part of infrastructure and switch back. So hopefully I was able to answer your question. Okay, so moving on, cloud reference model. So that's the way how you can, in one picture, visualize what the cloud is. So we've got those infrastructure as a service that we mentioned originally. We've got platform as a service sitting on top, and we've got software as a service or applications. The cross-cutting concerns shown along the side horizontally, if you can read it, all those things which are related as the cross-cutting concerns, governance, provisioning, orchestration, monitoring, you name it, SLA management, they must be present at every layer. Whether you deal at infrastructure as a service platform, or you would need to have a very good visibility into the runtime of your system. So infrastructure as a service in this reference model is shown in all its entirety. All 9 yards are shown. So you would have facilities which deal with the actual premises. The secure access is mandatory. You would have the racks of computers, air conditioning, electrical supply, and all other stuff which makes the whole thing tick. Hardware is also the physical assets that are provided to you and not visible to you tangibly as a tangible asset. So those two layers are provided by the cloud vendor. And you would be able to interact with hardware by using some sort of abstraction layer. So this is where virtualization comes in. So it's virtualization not only of the servers, it's also virtualization of the storage, networking. And on top of that, you would have the platform as a service, which helps you with building quickly, deploying and getting them up and running solutions from the building blocks within the runtime that is given to you. And you would interact with the underlying system using the API. So that API provides a sandbox environment which doesn't expose the underlying hardware. So as you can see, that input-output operation would need to go through all the layers, and this interaction is blocked at the API level. So you would be redirected. There would be a proxy service running which would take charge of that particular low-level transaction. Okay, so I guess that's pretty much it for this slide. Some of the, I guess, major players in every space. So we've got infrastructure as a service, platform as a service, and software as a service. I also included that metal as a service, which is a niche offering, and there are very few companies in this field, but I wouldn't be surprised to see that some people are driving this more aggressively. Currently, Canonical, the company behind Ubuntu Linux distribution, is very active in this area. Infrastructure as a service is represented by such companies as Amazon Web Services or AWS, Azure from Microsoft, Google Compute Engine. Google recently joined infrastructure as a service 2 or 3 years ago, quite recently. They were represented on the platform as a service segment. OpenStack or Rackspace. OpenStack is an open source cloud, and many people build their on-premise cloud-like solutions, deployments using OpenStack. So at infrastructure as a service, you would get low-level, the lowest possible accessible system resources in the form of the compute service, which are backed up by virtual machines, block storage, network load balancing, metering, and some other services. So platform as a service gives you those runtimes of choice. So you have a choice to choose between like modern languages such as Go, for example, language from Google, or proven systems like Java, which you can use to upload your WAR files, the web archives, into the container and have your system up and running in a matter of minutes. And platform as a service vendor would provision the necessary capacity. And at the platform as a service, you have that true elasticity built in, where the increased traffic would be matched up by the additionally provisioned resources in the form of virtual machines that you don't have a very fine control over. You would need to go with infrastructure as a service if you want to. Players are Amazon Web Services, Microsoft Azure, Cloud Foundry. You can add IBM Bluemix. IBM has realized the potential of that model. And if you're an IBM shop, I would recommend you to take a look at IBM's Bluemix, which is, by the way, built on Cloud Foundry. Cloud Foundry leverages what used to be Spring Source software or Pivotal. Lots of things if you are coming from that Spring, like writing applications for using Java, Cloud Foundry would be a place to go for you. And software as a service, you would have all those applications which are near and dear to all of us. You would have Apple iCloud, Dropbox, Gmail, Salesforce. Salesforce was the first, and Salesforce also purchased Heroku, and they moved on to the platform as a service. So things are kind of moving up and down. So Google moved from platform as a service using Google App Engine, and they exposed the Google Compute Engine, while same was, I guess, with Azure. They went this way, and Amazon went in the opposite direction. So they exposed the services as infrastructure as a service, and then they came up with that beanstalk platform as a service. So things, as you see, are quite volatile in this area. And metal as a service, it's probably worthwhile to look if you really want to get full control over your infrastructure. So that's how you would build your hybrid clouds. I mentioned that. That was a question from the audience. How would you, I guess, combine that on-premise private cloud or data centers with the public cloud? You would need to establish, normally it's just a matter of getting in touch with your cloud vendor and find out how you can best do it. They also provide wiki pages, instructions, how you can set up and expose your LDAP or Active Directory users to the outside world. So you would be able to map users that you maintain locally to those users which would be operational on the cloud. So the private cloud would probably be handling, as I said, the majority of work will be doing the most of handling the most of requests, but when the need might be, you would be able to get to that private cloud. Normally that would be the arrangement. You would have private virtual cloud inside the public cloud. You would have to pay for that, but the cloud vendor would reserve the necessary capacity for you so that you don't have a nasty surprise that all of a sudden you have very high latency in that particular region or particular data center that you are planning to use for that hybrid cloud. So hybrid cloud is the way to go, and it's very nice to combine, manage your mission critical applications, very secure specific applications inside your cloud, and outsource computing to the public cloud, where you would just crunch data on anonymized data, where you would purge user information and process it as just some dummy data. And then when you get the results back, you would do the lookup, and you would probably maybe decrypt some of the information. Whatever the arrangement you want to go into, it's possible. So virtual machines are important. Virtual machines is the core of the cloud infrastructure. Normally you have control over virtual machines, how to spin off and manage their life cycles, to suspend them, kill them, terminate them in infrastructure as a service. But some of the platform as a service vendors give you access to those virtual machines as well. There is a variety of virtualization technologies available out there. So you would have the Hyper-V from Microsoft, KVM, which is kernel-based virtualization technology used for Linux, and Zen, and some others. And you would be dealing with different virtual machine monitors, but everything would be exposed to you in a very nice API, whether you would be just command line or RESTful, REST-based API, or available as widgets on a dashboard for administration. So there are some arrangements to ensure that your virtual machine would not be affected by some rogue tenants who are reusing the same physical machine. So there is a pool of hypervisors that are created by cloud vendors, and some other things that help you to spin off your machine and more reliably run it in isolation from possible effects from your other very noisy, chatty tenants. VMs are booted from bootable machine image, and there are different types to create those images. And you can provision operating system of your choice. It can be Microsoft Server 2012 or whatever you want, or it can be Red Hat Linux Enterprise Edition, CentOS, Ubuntu, you name it. So everything is available on the cloud. How would you normally do this? Again, even though it might sound as very complicated, but things have been streamlined to an extent where you would be just clicking on those links or just using those scripts which would help you to perform operations in a very nice, pleasant way. For example, Amazon gives you the Amazon machine images, which is just packaged up environment, which contains all the necessary binaries for operating system, plus some additional hooks that would help you to to give you a better control of that virtual machine. So you can insert the say certificates of sorts in the image, and you would be interacting with the system not using your password but rather your private key. So that public-private key arrangement can be enforced at this level. Okay, so back storage is very important, and that's where you would be provisioning virtual machines with those additional volumes. By default, you would get some ephemeral storage which gets destroyed when you stop your virtual machine. So in order to persist, you would need to get that durable block storage. Like Openstack gives you a Cinder service. In Amazon, you would have to deal with elastic block storage to get that 5 gigabytes of storage that you want. Then you would need to partition it and mount it, or use any other tools that would help you to attach it to your virtual machine. So some level of administration would be required. If you, this is normally happens at infrastructure as a service cloud. With platform as a service, you don't deal with that level of complexities. Object storage is given to you as a way to store large objects. Sometimes you might want to store terabytes of data. Some systems support up to 5 terabytes of storage. You would probably be able to store more as long as you can partition your large files. Amazon Web Services give you S3 and Glacier. S3 is a primary runtime system that has very low response times, and Glacier it's a archival type of service which much longer retrieval time of objects, which is much cheaper, quite naturally, and you can use it for storing some archival data that you would just need to keep there for to comply with some regulatory or corporate standards or requirements. Some other systems from other vendors are listed here. So that's how you would be coping with the computing demand in traditional way. No matter how accurately you provision, there would be a spike of user activity, that actual demand, that error, that red arrow, which goes above that provisioned capacity. That results in user dissatisfaction, lost businesses, and overall bad reputation. So no matter how effective you are in provisioning, those are your investments in dollars, right? And then you realize that it looks like we are going up, so we need to provision additional stuff. So that would be our next investment. We roll out stuff. We've got the new data center, and we are fine up to this moment in time, where the actual demand would overwhelm your infrastructure. So that provisioning is always a pain, and that's how things work in an elastic way in the cloud. So that actual demand curve, no matter how sharp it can shoots up, that scalable, elastically scalable cloud hardware would always be ahead of the game. There will always be some level of protection, that kind of a headspace between the actual resources available and the demand, meaning that you don't have that situation where your demand would exceed the supported environment. It's not as easy as shown in this slide. You will need to do certain things, like to engage some of the services so that there would be some sort of a trigger that would start the process of provisioning additional resources. It depends on the cloud with which you deal with, but the ultimate result on the dashboard of your C-level executives, it would look like this. So you can sell them on that specific aspect of the cloud. So cloud benefits, that's the economics. Cost savings, definitely you would lower or eliminate your fixed costs. Variable costs would go down because your operations probably would be dealing with much less work. And better service quality, availability would be improved because you can have leveraged that high HA principles, high availability of infrastructure, quality of service, by just deploying your applications in different data centers or even in different regions, like geographical regions. Cloud vendors give you this choice, meaning that if a particular, I don't know, like south or north or east-west data center goes down, they of course run on different power grids. The other system which is distributed in the opposite geography of your jurisdiction, whether it's a country or whether it's a province, you would be able to continue service your clients. So that availability improvement is a critical factor as well. It comes at practically no cost. You just need to double your bill so that you would be able to deploy the same system in another data center, but it probably would be worth every penny of it. Better team composition, that DevOps model, which has been popularized quite effectively and aggressively recently, is very suitable for cloud model. It would help you to realign your workforce, because now developers would be able to provision resources and perform all those traditional operations tasks themselves. It's not going to say that operations would be downsized. Most likely they would be probably repositioned inside your organization to address some other more urgent problems. Okay, so user cloud interaction is the client server type of paradigm. So those people who have enough, I guess, years behind under their belts, you would recognize that client server interaction. So that smart agent would be anything which understands all those protocols to invoke any services in the cloud, which can be exposed in some sort of a contract, whether it's a WSDL file, WSDL, WDL file, or it is something that you just know how to invoke a cloud service. Typical cloud services that you can get on the cloud are application services, storage services, and monitoring services. It's just a subset of those which you would probably most likely be using in your day-to-day work. Some of those are exposed to you only on the IaaS, infrastructure as a service platform. Others are also available on PaaS cloud platforms. And you can build very nice compositions and orchestration of those services. So application services, some of those which most likely would be looking up for messaging, for building your message-oriented architectures, email, caching, very important to reduce your cloud bill, because every hit against your data store would count as a hard coin. So in order to prevent that retrieval of the same response, you can use a caching service, which is available in all platform as a service and IaaS type of clouds. Just look for that and make sure that you understand how best to use caching. And specialized application services help you with lots of things, such as probably performing some business analytics, like MapReduce based, or some other systems. Maybe you would perform image manipulation or transcoding some codecs, things like that. So messaging is represented by the actual service running on the infrastructure. In case of Amazon Web Services, you would have a simple queuing service, which is definitely not as sophisticated as IBM messaging products like WebSphere and Queue, or like Tivoli, TIBCO, or any other services of that type. But it gives you a very modest support in this area. Normally you would use it where you would like to build systems where sender and receiver might not be available at the same time. And you can accumulate those requests somewhere in the storage, and when the server or receiver comes up, you might want to do this to save on the storage or to save on the computing cycles, just to bring your bill a little bit down. Then that system would be more efficiently processing that a steady load of requests. And then when all the requests are processed, the system can go down again. So it's just one way to save on your bill. You would normally have an API of sorts, depending on what system you use. It might be Java-based API, or it might be C or Go or C#-based API. And you would have a way to adjust some of the configuration properties of that system, such as you would create those queues on demand. You would specify the maximum size of the message, as well as setting permissions, who can perform which operation, whether it's just read-only permissions or kind of a message create and insert, or put the message on the queue permissions, things like that. So you've got quite extensive control over that. So specialized services that I mentioned, most likely they sort of created around some of the business needs. And Elastic MapReduce is one of those managed Hadoop frameworks which is available. By the way, those things, that's a screenshot fragment of a screenshot is taken from Amazon Web Services, but similar services exist in other platforms as well. For example, on Azure Microsoft platform also has a Hadoop framework. And that's very nice and helpful way to not provision, in this case, a cluster of Hadoop computers. You can provision hundreds of machines just by clicking clicking through that wizard-like processing of your request, and then eventually you would have the computing power sufficient to process your task within established time. It might be a matter of minutes or hours. It's up to you. You can do it by yourself. You can self-provision the required computing facilities, resources. So what are the negatives? There is a question. What are the negatives, pros and cons of going with cloud approach? I would say security, that's what comes first to mind. So you would be aware that Big Brother is always there. If you do business in kind of a standard way, you don't have to be afraid of anything, then that's probably the way to go. But in some jurisdictions, like in European Union or in Canada, there are some restrictions which prevent you to go to the cloud with user information, whether it's health-related information or personal information. So it's just the federal law which prevents you. So that would be the limit. I guess you need to decide for yourself, for your company. So while certain things might be, I guess, the negative kind of negative has a negative connotation to it, might be a very positive aspect or pro for other people. So look for yourself. Storage capacities can be provisioned on demand, and for example, Amazon gives you all the whole slew of different types of storages. You can get archival storage, runtime scalable storage, where you can expose your objects to the outside world by just setting up the right permissions. Imagine you upload some PDF files for your help, and you probably would have terabytes of those PDF files. And rather than you build your own system to expose that help, you would put them on S3 storage and just perform a one-time operation to give to allow your bucket to be viewable from the outside world, and voila, in probably 5 minutes you will be able to provision the necessary capacity. It's fantastic, fantastic thing. That's, by the way, how Dropbox builds their business. The Dropbox, if those of you who use it, they build on top of S3 and some other services. Cloud utility services give you a way to manage infrastructure components. So you can use load balancing to front, to use it as a proxy to front a cluster of your EC2 instances on Amazon Web Services. Similar techniques exist in Openstack, Rackspace in Amazon Azure, and Google Cloud Compute as well. You would have auto-scaling service, which would allow you to provision that additional capacity that you need, the computing capacity, as demand increases. So you would need to enlist the auto-scaling service. Monitoring services give you visibility into the runtime situation of your solution in the cloud. So we've got a couple of classes that target architects. We've got cloud computing for architects, and we've got also Amazon Web Services for solution architects, which deals mostly with Amazon aspect of the cloud. I guess we don't have much time for taking your questions, but still, I am available to take your questions. We still have time. What I would say, it doesn't cost you very much, even if as a private individual, to start trying out cloud. Most likely you would be given a tier of or certain quotas that you can use without incurring any charge. All you have to do is just give your credit card, and whether it's Google or Amazon or other services, and you will be able to get through and start working probably within 10-15 minutes. You'll play around, see for yourself, and if you can make a good case, just go after your stakeholders and see how you can explain the benefits of the cloud after playing around for yourself, and see how you can start building those hybrid clouds and probably moving part of your business to the cloud without affecting your core businesses. Start with small projects, sort of a pilot projects, proof of concept type, and just gradually build a portfolio of successful projects that run on the cloud. So I would say that's the way to go. But as the original question was whether it would supersede or negate the need for the current infrastructure, it's not going to happen. It will always be and your on-premise deployment and part of your business on the cloud. Okay, so the question is, do these courses run one after another? No, they can run in parallel. Those are independent courses, and they have different focus. Can we complete both of them in 4 days? I guess yes. You can get in touch with our sales people and get those clarifications. So it's anything is possible. So you can do this and that. So that's all the time we've got for today. I would like to thank you for your questions, for attending this webinar. And I really wish you to start, whether you'll be going on your own or whether you'll be learning as you go or taking the classes, it's up to you. Sometimes it would be, I guess, better for you to get a very short, packed with labs class that would get you up to speed quite quickly. Okay, but you have to decide which cloud you would like to use, because clouds are different. Now you've got the idea of fundamentals, you would be able to, I guess, proceed. That's all the time we've got for today. Thank you very much, and I wish you every success. Bye-bye.